All right, so the recording has begun. This is the Sunday edition of our Bgcse classes. We are studying on a Sunday, right? Getting the work in before these exams begin. And I want us to look, at least for the beginning part of the lesson, just getting some good practice on functions. I really want you all to actually do it on your own first, actually, right? So make sure you have a pencil or pen to actually write it out and to do it out on your own. Because through the week we don't really have that time to really do that, but I really want us to have practice getting it out, and ask me any questions that you need to ask me during it. And so I looked at several papers that had functions questions, and this one came from 2008 paper 3. All right, and so we're going to begin with this one. Notice that when functions come, they come 2, 4, 6, 9, 10 points. So if you do not know functions, you're going to lose whole 10 points. And so it's important that we actually get a good understanding of this. So I want you to do A and B. Right, let's focus on A and B first, and then we could discuss our answers. All right, so A and B. I'm gonna set the timer for a minute. Quickly do A and B for me, please. All right, the timer has begun. All right, that's time. Any answers for A, please?
Can I get an extra minute, please?
For A, at least for A. Any answers for A? No answers for A?
Yes, I finished it. Could I get like just one more second?
A?
Yeah, no, because I started late.
Oh, wow. Anyone else for A?
Negative 16.
Negative 16. Okay, so we get negative 16. Anyone else? Sorry. So we got negative 16. Anyone else?
I agree. Negative 16.
Okay. All right.
Yeah.
All right, now do B for me, please. You say you need another minute for that, or are we good?
One more minute.
All right. If anyone else got negative 16, let me know too, please. Or if you got a different answer from negative 16, let me know.
For B, I got x equals 15. Yes, sir.
All right, Ricardo. Who else I have? Floyd, Odisha. I'm not hearing from y'all. Any answers from y'all?
That was me who gave the first one.
Sorry. My bad. I meant Mr. Bethel and
Two. Sorry. You want us to do C as well?
if you finish, you can move on. That's fine. You can move on. All right. All right. So let's tackle A first, and then we could do B.
Good day.
Yes, sir. Good day.
Good day.
Yeah. Mr. Bethel, what's happening? I ain't hearing from you at all.
My mind blank, my paper blank.
Oh my goodness. All right. All right then. So we're trying to find the value of f of 7. Okay, we know that the function f is the following. They give us what f is. All right, so this is a. We're trying to figure what a is. They tell us what f is. F of x is gonna be equal to
Is it negative 16?
that's what the rest of them got already. Um, one moment. Okay. All right. So wow. Okay. All right. So f of x is the following. F of x equals to 5 minus 3x. But we're trying to find f of 7, right? And so all we're gonna do is substitute 7 wherever we see x. So it's gonna be we replace 7. We replace x for 7 minus 3 open bracket 7. Sorry, let me do it properly. And so f of 7 is going to be equal to, well, we have 5 minus, what is 3 times 7?
So, 3 times 7 is 21.
3 times 7 is 21, very good. And 5 minus 21
Negative 16.
is negative 16. I'm glad that y'all said negative 16 and not positive 16. So good, that's how we get that. So that answer was right. Now for B.
So you don't do nothing with the 7 in front then?
No, that's just what's it saying is that the value of f of x at 7 is negative 16. That's what that's saying.
Okay.
Next up, we want to figure out b. Now, Nancy got x is equal to 15 for that one.
I got 15 as well.
Got 15 as well, okay. So it's gonna be, so you're trying to figure out what x is when g of x is equal to 11. So you want the value of x, right? That would make this expression equal to 11, right? So what must x be to make this expression equal to 11? Okay. So g of x, right, equals to 11. We substitute for g of x. We know that g of x is equal to this fraction that we have, which is x plus 7 divided by what? Divided by what?
2.
5 by 2.
2 equals to 11. And so we're trying to solve for x here. What's the first thing we're going to do?
Cross multiply.
Cross multiply. Very good. So we put this over 1 and we cross multiply. So 1 times x plus 7 is simply x plus 7. And 2 times 11 is simply 22. And so what we do here is we send the 7 over the equal sign. And so we have 22 minus 7. So x equals to 22 minus 7. And what is 22 minus 7?
15.
15.
So the value of x that would make this expression equal to 15 is equal to, equal to 11, is 15. And we always verify that, because if we put 15 here and we add that to 7, and we divide it by 2, what we have is 15 plus 7 is what? That's 22. Divided by 2, that'll give us what? 11. Okay, so that's that. Any questions on this? No? Alright, so let's move on to the next one. Alright, so C. A simplified expression for...
I got an answer, but I don't know if it was right, because I had to rearrange the order to answer.
Let me give you a minute to do that.
Basketball.
I already did it. I just saying. I don't know if it's right, because I had to rearrange the order.
No problem.
Everything's gonna be all right.
What did you get?
I promise.
I got 12 minus 3x over 2.
That's exactly.
You said 12 minus what?
3x over 2.
Okay, 12 minus 3x over 2. Anyone else got anything? Alright, that's time. So let's do it. You see this expression here in this exam, they wrote it the way that I like to see it. That really shows you which one is the parent and which one is the baby. So which one is the parent in this case?
The G.
And f of x is the baby. And so we call these type of functions, anyone remember what we call them?
Is it composite?
Yes, sir.
Pardon me?
Yes, sir. Composite function.
All right.
Very good. Ricardo, make me feel at least I teaching someone. That's good. Let's duplicate this. All right, a simplified expression for g of f of x. So that means that now they could write this. They usually write this sometimes as g f of x, right? So if you see it like that, don't be surprised. It means the same thing, right? We put in f inside of g. Okay, so we have g of f of x. Excuse me. G of f of x not gonna be equal to, well, we already know what g is. G is x plus 7 over 2. So instead of putting x, we're gonna put f of x. It's gonna be f of x plus 7 divided by 2. Okay, and well, we know what f of x is. F of x is what? This expression, right? 5. Oh my goodness, sorry for that. F of x is going to be 5 minus 3x plus 7, right? All divided by 2. And so f of x is indeed this particular expression f. Now after that, we just, gather the like terms and see what we could do with that. So we know that 5 and 7 are like terms, so it's going to be negative 3x. We don't really like to write it like that. Let's do 12 first. So it's going to be 5 plus 7 minus 3x. And we did it because we combined the 5 and the 7. Divide that by 2. 5 plus 7 is nothing else than 12. So it's 12 minus 3x divided by 2. And that is the composite function right there. I think someone got that. Nancy. Yep. Yeah, very good, Nancy. Awesome.
I have a question. So I didn't have to rearrange it because I had to rearrange it to get 12.
Rearrange what?
Okay, so like you see what you have in blue?
Yeah.
I wrote, I didn't write that. I actually wrote 7 in the front, and then I put in bracket f of x. I was struggling because I didn't know if I could have rearranged it.
Well,
Because I made it, because our x was in the front, so I try to put the number in the front, and then I swap it because you say it doesn't matter what sign. I remember you saying something about it don't matter once it one, like they could be on either side once they don't have an equal sign. So I figured, or I could just do it the way you did.
well, I'm not sure if your rationale for switching it is right. But I mean, you got the right answer. Now, the true reason why we could combine these, why you could switch it, is because this is addition. Okay, that's the true reason why it doesn't matter how you. If I put 7 plus f of x or f of x plus 7, it doesn't matter because this is addition. But if this was subtraction, I couldn't do that. Okay, I couldn't just switch. You can't just switch it. All right. So be careful with that. It's addition. You could swap them. You could put the 7 in front of the f of x. That's no problem. Now, but the proper way I would say to think about it is just to substitute it as is and just look for like terms. That's the way you think about it. That's a better way to think about it instead of thinking about as you switch it. Okay, so just substitute it and then find the like terms that are there and then simplify it.
Mr. D,
What's up?
I have a question. Did you carry the 7 to the left?
Okay, so I took the 7 and I connected it with the 5 because 5 and the 7 are like terms. So that's why I combined them.
All right.
Now I could have put the 5 by the 7.
Yeah, I was thinking like that.
Yeah, I could have put the 5 by the 7. That's fine. But it doesn't matter. Because if we have negative 3x plus 12, it's the same thing as 12 minus 3x. So it doesn't matter.
So in this case, if I had to carry the 5 over, would the 5 turn to a negative?
No, because the 5 is
Stay
positive.
positive.
The 5 is positive. This negative refers only to the negative 3.
All right.
Yeah. Okay, so that's g of f of x. If you have any questions, let me know. Otherwise, we move on. Next, it's time to find the inverse. So we trying to find the inverse of it. So let's try it. You know what? Let me give you a minute to try it on your own. So the time has begun. Try it on your own.
I got my answer already. My answer is 2t minus 7.
T? Where do you get T from?
Oh, sorry, I supposed to put that. Sorry. X. Sorry, I when I swap it, I don't use X. Sometimes I use T. So, but it's 2x minus 7.
2x minus 7. Okay. So you mean that G inverse of x. Alright, that's time. You say 2 what?
X, 2x minus 7.
Okay, good. Alright. So let's try. So we have g of x. That's the first thing we write. G of x equals to x plus 7 divided by 2. The first step that we do is what? What's the first thing we do?
Substitute g of x to y.
Yeah, we swap it.
We set y equals to g of x. Y equals to g of x. Anyone remember why we do that?
Save ink.
Because we have to swap it, right?
Yeah, like Mr. Bethel said, we don't want to keep on writing g of x all the time, so we do it in an effort to be concise and easier for us, right? All right, so the next thing that we do at this point is what?
We separate x and then we put y.
Separate, what you mean?
As in we rewrite it, but then y would be in the x position. and X will be in the Y position. Like you swap it.
Very good. So we swap X and Y. Very good. So it's going to be X equals to Y plus 7 over 2. Good. And then after that, what do we do?
Cross multiply.
Okay, so we cross multiply. 2 times X is
2X. Let's cheat, man. Come on.
And 1 times Y plus 7 is Y plus 7. The next thing we do is we send 7 over. So we have 2X minus 7 equals to Y. And so what that means is that Y equals to 2X minus 7. Therefore, thus G inverse of X equals to 2X minus 7. All right, exactly what Nancy said. Very good. Nancy, you're getting pretty good at this.
Practice and videos. Practice and the videos. Trust me, when I first started this, I was crying because of the headaches. But now, I know like the back of my hand.
Yeah,
Practice.
I can see it. I can see that. Very good, Nancy. Very good.
Nancy was an inspiration.
She need to be more than an inspiration. She should be a companion, not an inspiration. Y'all should be doing the same thing. Step after.
This ain't my yeah, Mr.
No. Don't give up like that. Miss Nancy, how you could let him go easy as such? You see how you quit in?
I know, right?
Quit in?
And then you would be my friend.
It's just the year the winners, man. This ain't the losers year.
You are part of the winning side. What you mean? When you're on my side, you're on the winning side. Come on. Have faith in yourself.
All right.
Change your language. Change it.
Right.
I am winning this.
Exactly. Oh boy. All right. So.
A serious question. I never saw E in my life. What is that?
All right. E is.
You use so much to try to know because that's a serious.
That's 3 points, right? That's 3 marks, right? We never did E. Yeah. But E is I wouldn't say common sense, but E is interesting. And it's important to understand what E is saying. You know how much ambulance I hear today? It's crazy, man. All right, so E. Given that f of x is equal to 5x, 5 minus 3x, and g of x is equal to x plus 7 divided by 2, find the values of x for which f of x is less than or equal to g of x. Okay, so when is, okay, so what they're trying to say is that this function, right there, is going to give out some values, right? This function is going to give out some values as it relates to this particular x. What I mean is that when x is 0, this function will give a value. When x is 1, this function will give a value. When x is 2, this function will give a value, and so on. The same thing with this. When x is 1, this function is going to give a value. When x is 2, this function is going to give a value. When x is 3, this function is going to give a value. So both of these functions, you could think of functions as machines, right? You give them an input and they give you an output. You give them an input, they give you an output. So they're trying to say, okay, when is this function's output going to be less than this function's output? Because both of them are going to be giving you outputs, right? They're going to be giving you outputs depending on what x value you put into them. And they're saying, okay, which values, right, of x will make this function less than g of x, right? And that's kind of a nice way to think about it, right? Before we even actually get into the algebra stuff, right? That's why they don't want you to use graphing calculators, because if you had a graphing calculator, you would be able to see that immediately. Let me show you what I mean. So let's go on our graphing calculator, right? And we're trying to figure out the values of x where f of x is going to be lower than g of x. So we have f of x equals to what it was, 5 minus what? 5 minus 3x. All right, and then we have, so that's the equation of a straight line. So f of x is a straight line, right? And then we have g of x, right?
That's x plus 7
X,
plus 7 over 2.
right? All right, so let's look at these functions, right? So the blue one is g of x, and the red one is f of x, right? So let's look at it. When is the blue one bigger than the red one? All right, so it's easy to determine. No. So let's say at say let's say let's say we're looking at the point 0, 0, right? So let's say we're looking to let's start at the origin, right? So at the origin, or at let's say at the origin we have 0, 0. At this point they share the same x value and y value, so they're equal at this point. Oh look, okay, I got it. So let's look at the okay, let me show you what I mean by, I have the screenshot of this. I'll show you what I mean. Okay, so that's good. So let's consider at x is equal to 0, right? So x is equal to 0, right? The line x is equal to 0 is this particular line right there, right? That's the line x equals to 0 right there. Okay, good. So at x equals to 0, let's determine the functional values. So at x equals to 0, g of x is right here, right? And f of x is right, let's say here. So which function is bigger at x equals to 0? Is it g of x or is it f of x? Which one is bigger?
F of x?
F of x, good. So at x equals to 0, g of x is smaller than f of x, right? Now let's look at it at 5. So at x equals to 5, okay. Well, this one is g of x, right? And this one is f of x. So who's bigger?
G of X.
G of X is bigger this time, right? So what this question is saying is that when will G of X be bigger than F of X? That's what this question is saying. Like which values of X will ensure that G of X is going to get a bigger output than F of X, right? And well, if we look at these functions, we can clearly see that from here onward, you see that? From here onward, this function is bigger. You see that? I don't know if y'all could see that. Like from here onward, G of X is always going to be bigger than F of X. Because F of X going down, you see that? G of X is going up, right? And so from this point onward, G of X is bigger than F of X. Do we agree with that?
Yes, sir.
And then from this point onward, who's bigger?
F of X.
All right, so okay, so we can say that if we want to be specific, we can say when X is greater than, let's see what this value is. So when X is, this is the intersection point. So we can say when X is greater than this point 0.429, every time X is greater than this point, G of X is going to be bigger than F of X. We can see that. So what I mean is whenever X, this is the value of X, right, is bigger than 0.429, then the blue function will be the bigger one. What I mean by that is, and by the way, every time X is less than 0.429, F of X will be greater. And so what I mean is that, look at this is 0.429, right? Give me a number that's bigger than 0.429. X value.
1.
1, right? So at X equals to 1, right? So this is the value of X equals to 1. Who is bigger? Clearly F of X is bigger, right? Because it's higher than this one, right? Here F of X is going to be bigger because it's on top, and for this one it's
I mean, G of X.
G of X, sorry, it's bigger because it's bigger than the green one for X equals to 1. Give me another value that is bigger than 0.429.
0.450.
0.450, right? I don't know why you put me through that because it'll just be harder to show. But give me
I
something
go
that,
with whole numbers because
yeah, I
that's the
know.
only thing I can see.
Yeah, why? Oh my goodness.
2.
2, okay, 2 is easy. Clearly, G of X is bigger than F of X, right? So every time we go in this direction, because the values of X getting bigger and bigger, every time we are bigger than 0.429, G of X always is going to be bigger than F of X, right? Now, every time we are less than 0.429, F of X is bigger than G of X. So give me a number that is less than 0.429.
-2.
-2. So for -2, this is 1, 2, 3, 4, 5. So for -2 is going to be right here. So if we look carefully, this is F of X up top. This is G of X at the bottom. Okay, so F of X is bigger than G of X for values that are less than 0.429. Okay. All right. So what can we say down to this question? So down to this question, we can say that when X is what? Less than, no, when X is greater than or equal to let me use the symbol. So when x is greater than and equal to 0.429, then f of x is going to be less than g of x. All right. So that's the answer, right? Now, and we know that that's the answer because we can clearly see it based on the graph. Now, the only question I have is, they say it's for 3 points, right? And so, I want to know what technique they want us to use to, gather the 3 points. We know, obviously, 1 point is square.
No, I wasn't done. Sorry.
Yeah. We know that obviously 1 point is for the answer, obviously. But they want us somehow to do it by hand, right? Somehow to find this answer by hand. Um, there's several things that we can, ideas that we can say, right? If we were to do it by hand, me personally, um, this how I would make a case, right? That's what I would say. I'd say the first thing I would want to do is I would want to see where these two intersect, right? That's what I would want to do. And so I would say, so I showed you all how to do it the graphical way just by looking at it, right? Right. But imagine you didn't have it. You didn't have this to look at, right? Then you would have to do it by hand. You understand? And so the first thing you would have to say is, okay, let me see if these two things, if these two functions, let me see if they have an intersection, right? And if they have an intersection, let me see their slopes. And when I look at their slopes, I can tell you which one going upward, which one going downward. And so let me explain to you what I mean. So let's first find the intersection by hand. So the first step is find intersection. Okay. So this is if we're doing it by hand, not with looking right at the graph. So the first thing you need to determine, does these two functions have an intersection with them, right? Do they intersect somewhere? Now, we do know that already by hand. Let's say we didn't know that, right? So, is there some place where these two functions are equal? They want less than or equal to, but is there some place where f of x and g of x is equal to one another, right? Is there some place that they are equal to one? Okay, so we know what f of x is. F of x is what? 5 minus 3x. And we know that g of x is going to be what? X plus 7 divided by 2. What's the first thing that we're going to do here?
I would cross multiply. That is wait, I could do that?
Yeah, you cross multiply, or you could multiply both sides by 2. Either way.
Oh, I was scared.
So 2 times 5 plus, so we have 2 times 5 minus 3x is equal to, what is 1 times x plus 7? Simply x plus 7. Then we distribute, so 2 times 5 is 10, and 2 times 3x is going to be negative 6x. Good, and so this is going to be equal to x plus 7. All right, that's good. The next step we're gonna do is we're gonna send this over the equal sign because we want to put all the x on one side, all the numbers on the other side. So we send the x over the equal sign, and then we send the 10 over the equal sign as well. Okay, so we have negative 6x minus x equals to negative 10 plus 7. All right, and so what is negative x minus x?
7x, negative 7x.
Very good, negative 7x. So again, very good at this. Negative 7x is going to be equal to, what is negative 10 plus 7?
3, negative 3.
Negative 3, very good. Good, and so negative 3, we can divide both sides by what?
Negative 7.
Negative 7, very good. And so to get that x is equal to 3 divided by 7, because the negative and the negative will cancel. What is 3 divided by 7?
0.429.
0.428.
0.428. Okay.
9. I go with 9 because he rounded. I go with 9.
So that's going to be equal to 0.4.
9.
If we round
If you round,
yeah.
that's right.
Well, actually, I didn't wrong it. I just remember that on the graphing calculator, that's what it was.
I figured, I figured. I
Two decimal places. But can two decimal places work though? In this case, let's say I just would have rounded to 2 decimal places. Would that work?
For this one, actually, it'll be better to leave it as a fraction. Because if we do 0.428, that's approximate, or 429, that's approximation. So the graphing calculator gave us an approximation of the thing. It didn't give us exactly 3 over 7. Okay? So it's better to use, and that's why I'm glad we did it algebraically to show that the real number that we're looking for is 3 over 7, which is 0.429 to 3 decimal places, but this is the true value that we need. And so, since we know that this is where they are equal, so we know that these two functions are equal at f of x, at x equals to 3 over 7, or we can say 0.429. So that's where these two functions are equal. But we want to know, we already know where they're equal, but now where they are equal for, they want to know where g of x is greater, right? And so we already found the intersection, right? The intersection is at 3 over 7. So we can say thus, the intersection of f of x and g of x is well. Hello?
X equals 3 over 7.
Yeah, at the x value of what? 3 over 7. Good. So
I just the first time saying actually use words in mine, so you don't use words at all.
what? No. Remember, we trying to make a case. We trying to prove to them why we choosing these. We can't just say when x is greater than da 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 da. They can be thrown in the graphing calculator, right? And so we have to show them that, like, how exactly we know 0.429? Like, for real, let's be honest. How we know that, right? Nancy, how we know that?
Because we have to work it out.
Yeah, we had to work it out, but at first we used the graphing calculator. And so if in the exam you wouldn't have the graphing calculator. So you have to show them that you understand what this means. This means that this is where the intersection is, right? So that's the first point you make, right? Because remember, you're still trying to figure. Remember, up to this point in the exam, you haven't drawn this function. You don't even know how these things look, right? I mean, of course, they are straight lines, but um, you don't know exactly how they look with respect to one another, right? So you trying to piercing your way through. The only thing that you know thus far is that hey, they actually touch, right? Um, and so since they actually touch, you can now say, okay, well, they touch, that's good. Now, which one passes one another when they touch, right? Which one goes higher than the other, right? And so you can say, right? Now we can look at their slope. So we can say now that indeed the function f of x has a negative slope since what's the function f of x? That's what 5 minus 3x slope, which is what's the slope of that, which is what, negative 3. Thus this function is a decreasing function. Certainly the function g of x equals um, um, it was what, x plus 7 divided by 2 has a positive slope, which is what, 7x over 2. And this function is an increasing function. And then we say, all in all, when x is greater than or equal to 3 over 7, then f of x is less than or equal to g of x.
Mr. Biggie, I have a question.
Go ahead.
Biggie just put x equals 3 over 7.
Yeah. For the answer,
Yeah.
this is the answer right now. So what we trying to say, we trying to make a case, because the natural they trying to say which values of x is g of x bigger than f of x. That's what the question is asking, right? So you can't just tell them the answer. You have to tell them why you believe it's the answer. And what makes our answer the answer is several reasons. The first one is that, number one, the intersection of these two functions is at 3 over 7. That's the first thing. So That means that these two values are equal these two functions are equal at 3 over 7, and we can see that right there on the graph. So if we look at the graph, at 3 over 7, which the graph approximates to, they give us an approximation of, and if we go further, they would give us a greater accuracy. But we can see that these two functions meet here, right? So in your exam, what you're telling the examiners is that, hey, listen, we know that this function is gonna meet at this particular point. That's why this value of x is so important, 3 over 7. So we're trying to say, okay, this is like the turning point, really. This is the point where g of x is going to leave f of x in the gap, all right? So we had to first find that turning point, that point where g of x is going to be, it's going to ascend or go bigger than f of x. So we first had to find that point. So that's the intersection, right? The next thing that we had to say is not only is it important that that's where this function intersects, but we also had to show that, hey, this blue function is a function that has a positive slope, which means that it's going to get bigger and bigger and bigger over time. That's what that means, right? That's what that means. And we had to also show that the function f of x is a decreasing function, which means that it's getting smaller and smaller over time. You see what I'm saying? And so with those three combinations, the fact that number one, this is the intersection, the fact that this function gets bigger and bigger over time, and the fact that this function gets smaller and smaller over time, then that would mean that the values of x that would make f of x smaller than g of x would be this, when x is greater than or equal to 3 over 7. So it's a combination of those three facts that make your answer valid. Number one, you found intersection. Number two, you show that the function the f of x is a decreasing function. And number three, you show that the other one is an increasing function, which means that it will overtake that one. You just have to figure out where it overtake it. Am I making sense, or I should explain that again?
Yeah, I get it, but
I just
you
want
have
to
to say all of that.
like if you have to say all that in
Yeah,
one.
you have to. Like, okay, if you
The
don't
three
say,
dots?
like, if you don't say that, how I can know that, okay, this is interesting. Like, it's not a working. It's like you have to explain how you know that this is the case. Like,
Well, Miss Petit, won't I see it by the working in the question?
this? You mean this?
Yeah.
This all this is telling me that these two functions are equal at this point. That's all this is saying. You
So
want to tell me?
that the answer?
No, this is just telling me that this is just telling me that
Okay, how much points do you get if we just do the work and give us with T? Right now, it's that on a paper. Woo!
oh my God.
I feel it that one. That's
All
one
this is saying
week.
is, okay, all this is saying is that all this is, okay, if the question asks where the two functions intersect, then this would have been your final answer. You could have just put x is equal to 3 over 7, you could. But they ask, where is g of x greater than and equal to? You see what I'm saying? So it's not only equal to, it's greater
But
than.
Mr. T, didn't they also ask the value of x?
They say values.
How much points I get if I just do the work in?
If you just do this, you just show me that they are equal, right? Just tell me that they are
So
equal.
do I get a point for that?
You mean for?
So don't they mean like the values, like,
Yeah.
okay, when f of x is this, it is greater than g of x.
No, not.
When no,
They mean range of values, and that's what this is saying. Whenever x is greater than or equal to 3 over 7, that's when this one is going to be bigger. It's a range of values. Think of it. X is greater than or equal to 3 over 7. That covers a range of values. 1 is there, 2 is there, 3 is there, 4 is there, 5 is there, 6 is there, and so on. So that's what they mean. Which values of x, right? That this function is going to be bigger, right? If you want a shorthand version of this, then I guess you could say that f of x is a decreasing function. G of x is an increasing function. Then you can make this statement. All right. But I was just showing you why we know it's a decreasing function, right? Because it has a negative slope. That's how we know it's a decreasing function. And why we know this is a positive, why we know it's
So
mhm,
so we gotta say since f of x is a decreasing function and
yes,
g of x is an increasing function,
yeah.
then we could put this.
Then you can put that, yeah. All right.
I think I understand. We have to write it in a sentence.
Yeah, you have to
I see. I don't understand. So what I'm saying is, if I get to my working and put
okay.
this at the end, can I get 2 points?
And put this at the end, yeah, you can get 2 points.
No, just do my working.
And
Put
then
that one line.
this one line at the end.
Yeah, I get 2 points.
Yeah, I believe so. I believe so.
I know. I don't understand all that, and I
Why
know.
don't
I
you
just
don't
like.
understand all this? What is all this? Isn't it, what don't you understand about the first line?
I don't know what I mean.
I don't get it. What don't you understand about the first line? This is just saying that f of x is decreasing. We saw in the graph that f of x is going down it over time. Like how much more what do you want me to do? ABC, triangles, what? I don't understand.
Don't worry about it, Mr. Petit. I get 2 points. I'm a seller for that.
All right. That's how we do this one. So yeah, but I mean I don't usually see this one. It came on 2008. I don't know if it comes again. Let's see. So let's try 2009 paper and see if it's there. Okay, good. This is how it usually is, right? They just ask you for the value. They just ask you x where. So they just ask you for the simplified from. Then they ask you for the inverse. I guess they was just trying out e and seeing if that'll work out. But typically they only ask you from A through D, right? Typically, right? But in any event, if they do ask you for E, at least you know how to do it. All right. All right. So let's do A through D quickly. I want you for this one. I want you to find the value of f of 3.
So it's basically asking you to find the increasing function, decreasing function, and to find the intersection.
Yes.
So that's basically a 3 points right there.
Yeah, that's basically a 3 point sentence. But there's other ways you could answer. You could answer that question. You could use calculus to answer that question. Um, but then you don't really need calculus because you already know it's a linear thing. So you already know that you wouldn't need calculus, man. They're constant slopes. So you don't need calculus.
So that's a new one we doing now.
There's a new one. Please do it for me, please. It's 2009, paper 3. A, B, C, and D. Let me put my time on. 1 minute.
Mr. Petit, you could repeat the question.
This is the question now, right? What question you talking about?
What we doing?
This is a new one. What you
Okay.
Want me to go back or?
No, I was confused from it. I didn't see like this was a new question or the same.
Oh, okay. Yeah, I know they look the same, right? That's how they all is. They look alike.
For the first one, I get 8.
They got movie after this born.
Okay, so they say 8.
F of 3 equals to 8.
Alicia shared 8. God, there your voice, Miss Alicia. I was wondering if you was here or not.
I get 8.
You get it, okay. Good stuff. Now B, the moment of truth, right? Mr. Bethel, what you get?
I got 8, Mr. Batiste.
Alright, yeah, you say nothing. Or you just saying you get 8 because they say 8 too.
I just a little slower than them. That's all. I just get 8.
I got 11.
You get 11? You mean x equals to 11?
Yes, sir, I'm doing
Yeah, I get the same thing.
Okay. Oh. Like your maths geniuses in hell. X equals to 11.
I swear, all them ace in this examination.
I know, right?
It's more better who gotta catch up.
Hey, look, I can meet y'all in college, okay? So I can learn from y'all freshmen year.
I got 11, and yes, I did it by myself. I didn't copy anybody, just saying.
Okay.
I just blurred the answers and I tried to do it myself.
Okay. Alright, awesome. That's an organic 11, she's saying. You ready, Mr. Bethel? Organic 11.
My answer is organic too.
Okay, organic too. Alright. Organic too. Ah, boy, it's always the biology people.
My answer's made a carbon.
I got. Oh, I scared. I'm scared. Okay, I got. Let me tell you what I got now. Please don't laugh at me. I got -4 plus 5x over 2, or you could do it the other way too.
-4x what?
-4 plus 5x. Or you could do 5x plus, 5x minus 4. It's,
-4x plus 5x?
Yes, sir. Because you say we don't have to rearrange it over 2.
Over 2, okay.
I agree with Nancy.
You sure?
I agree. Okay. Alright, one says he agrees.
Okay, then I feel a little more confident then. I thought I was tripping out.
Okay, wow. Let's go to the inverse then.
Okay, let me make the inverse.
These answers right, but I just hope.
The inverse of f, right?
Yeah, the inverse of f. Yeah. So be careful. Do the inverse of g one time too.
I'll do them? Alright.
Alright, so let me do A and B. Yeah, still working on that.
Okay. For F inverse, I got y plus 7 over 5.
So f inverse equals to, go ahead.
Y plus 7 over 5.
Okay.
I'm going to do G now.
Yeah, do G inverse. So A is going to be f of 3. It's going to be equal to 5. Wherever we see x, we put 3 minus 7. So f of 3 is going to be equal to 5 times 3 is 15. 15 minus 7 is going to be equal to 8. All right, so those who got 8, very good. That was right. Now let's do B.
I'm sorry, what did Nancy get for D?
B?
D.
The inverse? The
Yeah.
inverse was, go ahead again, Nancy.
I got Y. I mean X.
Nancy, in your answer,
Yes.
do not use from.
Sorry, because how you say like do a thing? I just end up putting the Y there and I'm putting the X back.
No, what I
I'm
mean
sorry.
is,
It's supposed.
what I mean is, F inverse equals, that's why I want the answer.
X inverse.
F inverse.
I mean F inverse
Yeah.
equals X plus 7 over 5 divided by 5 or over 5.
X plus 7 divided by 5.
And then for E, I got G inverse equals 2x minus 3.
2x minus 3.
Yes, sir.
Okay. All right, these interesting answers.
I know that.
All right, so B is, well, we're trying to find where G of X. I never see Mr. Bethel more quiet in my life. G of X equals to 7. We know G of X is equal to 3 plus X over 2.
Oh, I could be wrong. So if you have something different, I feel scared to say it because F was a bit hard.
Okay.
Because I got the 2x 3 for the inverse of x, right?
Of G, you
But
mean?
not I didn't do G. Like I got that answer for the inverse of f. I don't know what I'm doing.
Oh.
Anyway, I don't know how that happened.
Be careful that you're using the right function. You have to use f of x, not g of x.
Oh, that's why. Okay.
So, but since you already did that, that means you already did E. So do D now. Okay, so what we do here? This is a lot of ambulance. Wow. We cross multiply 2 times 7 is going to be equal to what, 14? And then 1 times 3 plus x is going to be equal to 3 plus x. Oh wow, I wrote that absolutely horrible. So it's going to be 3 plus x. Next thing we do, we send 3 over the equal sign, so x is going to be equal to 14 minus 3. So x equals to 14 minus 3, which is 11. Okay, so x equals to 11. All right, let's do C. All right, so I'm going to simplify expression for g half of x. So we have g half of x. It's going to be equal to, well, we're going to put g on the outside, half of x on the inside, because it's a composite functions. And this equals to, well, that means going to put 3 plus what? Half of x divided by 2, and this equals to 3 plus, well, f of x is equal to 5x minus 7 all over 2. It's going to be equal to, what we could do is we could take the 3 and put it over in the back of the 7. And so it's going to be 5x minus 7 plus 3. Or we could have taken the whole negative 7 and carried by the 3. Divided by 2, we get what? 5x minus 7 plus 3 is what?
Negative 4.
Yes, negative 4. And so we have 5x minus 4, or like Nancy said, negative 4x plus 5x divided by 2, same thing. Anyone else got that? Before I put it on the screen. I guess not. Very good, Nancy. Good stuff. So let's do D.
You can spray, but you ain't.
Well, I said that's how easy it is.
Yeah, so interesting they are.
Interesting. They ain't interesting. It's so straightforward.
Yeah, but a lot of things like this, so you get trip up, man.
Oh, okay.
When you think you're doing the to simplify it, then you don't have to do the inverse. You mix up the inverse, and then.
Well, that means one thing. You need to practice.
I got to practice a lot of stuff, not just this.
Except for bio. You get that in a bio.
Yeah, that's the only thing, though.
Oh, boy. Listen,
every year I should have just taken one. That's what happened.
I give you bio. I ain't got one. Easy. Okay, so f of x equals to 5x minus 7. But that ain't realistic though. Taking one every year. No man. That ain't realistic. Do it under the pressure that all students do it under. 7 or 8 one time. Okay, so the first thing we do is we set f of x equals to y. Right? It equals to 5x minus 7.
You forget to divide that by 3, by the way.
Y divided by 3.
No, I mean 7 or 8. Get divided by 3.
No, but he's doing the inverse of f, though.
No, we're talking about something else.
Yeah.
Okay, the next thing we do is what?
I carry the 7 over. So you want to divide both sides first? What?
You want to say x equals 5y minus 7.
That's so cool. So what we doing? We rewriting it as what? That's the answer?
No, we interchange x and y.
Miss, we said that already. We on the.
No, we ain't change x and y yet. All I did was f of x equal to y. That's all I did.
Oh, okay. Well, now we change them.
Thank you.
Sorry. 5y minus 7. We now carry the negative 7 over. Right. Plus 7. Yeah, plus 7.
Equals to what?
5y. Then we divide both sides by 5.
Divide both sides by 5.
Yes, sir. And then 7 over 5. Wow, Nancy, you're creative. How you get that answer?
So that therefore y is equal to x plus 7 over 5. And so therefore, thus, f inverse is going to be equal to x plus 7 divided by 5.
I need a break.
A break from what? Biology? I know, right?
I taking a 20-minute break to refresh my mind.
What is the excuse? We didn't even have bio today, and you just finished out a whole day of rest.
I need to walk around the corner.
That's how I felt the other day.
All right, so f inverse equals to x plus 7 divided by 5. Anyone got this? Anyone have any questions on this?
I got it, but I missed a step. Let's look at the same answer. Because it was like that, I didn't do like the next, like you see how you flip it? because it was like straight out and there wasn't nothing, it was over anything. So I didn't flip it. I just do it, and then at the end, I just swap it. I just put X back in the same spot. Like I swap it at the end, and I just.
You mean it's
put. Yeah, that part I still had X on the same side, and then I had Y there, and I just didn't swap it until the end because I thought I wasn't supposed.
I didn't swap it. What I did was I wrote the same thing. Y equals to X plus 7. Y. I just put Y on this side and this expression this side. I didn't interchange them. So you don't interchange them back. You understand? I didn't interchange them back. I just put. I just want, it's common to have the one that is the subject on the left. I just write it like that. Okay. This step is unnecessary. You don't need to. Right? You could from here already know. Once you already know what Y is, this side is the inverse. You already know that. But I just wanted it to be like that. So that's
No, what I meant was like from the beginning where you have all that equal to Y, I was just carrying everything over to add to Y. So like at the end, I just changed it to X because like I had Y equals 7/5, and at the end I just I know that it's not Y, so I just gone in and I just my final answer I just put X. If you know what I mean.
I have to change it from the beginning then. That's how we did it.
Okay.
All right, so that's that. So let's see what we get for G. We see D. Yeah, let's see what you get for G of X. So G inverse is gonna be what? So G of X. Wow, I can't believe it's only 635.
You want it to be 735?
Yeah. We started 5-8. Time is needle along.
Yes.
So what do we do now? We set what?
We turn all of that to Y, and then we flip it.
X divided by 2. Then we interchange X and Y. So X equals to 3 plus 5 divided by 2.
Can cross multiply.
Cross multiply. So 2 times X is 2X. 1 times 3 plus Y, which is going to be 3 plus Y. V.
Carry the 3.
Yes.
So 2X
minus 3 equals Y.
And so we write Y equals to 2X minus 3. And so thus X inverse, or G inverse, plus G inverse of X is going to be equal to 2X minus 3.
I got the first 2 right, and then this last one.
Okay. So
I'm still trying to understand that.
Miss McGee.
Yes, sir.
Can we do one more? Again, I ain't up now.
All right, I'll do another one. No problem. All right, so don't let the composite function one get you. You don't want it. And the inverse is where people get in trouble. Okay. So we did.
I'm kind of proud of myself that, you know, so practicing late at night wasn't a waste of time.
Yeah, I proud of you too. I'm like, wow, Nancy got on the first try. What is this?
While Beth was sleeping, I still came and get it together.
Okay, I like this one. This one is an interesting one. Interesting. I like how they put this. So, I wonder if I want to give this one. Wait, let me not give this one yet. This one kind of it's too different. I want to gradually progress. So, let's see what they have here. 2004. Let's keep that in mind. Let me see what they do in 2015. That was we did 2016 one and we had to do that. Let's see. Oh yeah, we did this KFT. Let's try 2019. Let's see if there's any luck.
We did this too.
Alright, so I guess we'll have to settle for okay, wait, before we settle for let's go back. Let's go 2001, see what they're saying. That's almost 2001, 2 decades ago. Today's answer is much different. Much different.
These look easier back then.
No, sir. You think so? It's what paper one. It's paper one. That's why. That's why it's paper one. I don't want to go too far back because they don't really write these exams like this no more.
They change it up every few years, eh?
Yeah, they do. But I mean, like, they don't have to, like, how they have section B and whatever, you have to choose and stuff like that. Okay. See how it is. Simple this one is. Do number 7. Yeah, do this one. I think this is a good one to try before we get into the other ones. So do number 7. Do that. Everyone should get this right. This was pretty easy.
I hate that word. The function was undefined.
Alright, so let's try. Notice that they changed the symbol. It's still the same thing, right? But write it how we usually write functions. You wouldn't be in any problems. Even though they write it in this funny way. I used to hate it when my teacher writes functions like this. Oh my goodness.
So we could take out the arrow and put the equal sign, and then we could take out the double dot and put brackets. Is what you're saying?
Yeah,
All right.
that's what it means, really. You know, both of them mean the same thing. few more seconds left. All right, that's time. What we have for AI?
I get 0/2.
You got 0/2.
I just got 2.
8 seconds.
0/2.
0/2.
Yeah, which equals 2. I wanted to put
Nancy,
0/2.
Nancy, what is 0/2?
0/2 is 2.
Use calculator, please.
0/2. No way, 0? I leave it at 0/2, so I said I would get it right. I left it at 0/2.
You want to simplify it?
I'm putting 0 now. Equals 0. I didn't put it. I'm using my calculator, you see, so I leaving it as a fraction. You know what I'm saying?
What we get for?
So,
Go ahead, Alicia.
so you see how you got 0/2, so you don't just put 2. 0/2 is like a fraction, so you have to simplify that.
Yeah, simplify it to 0.
Oh.
Yeah, 0/2 is 0, 0/5 is 0, 0/9 is 0, 0/10 is 0, 0/anything is 0.
Oh, so 2 wouldn't be the answer. I thinking that just the 0 in the number. Okay, alright.
Yeah. All right. What we got for AI?
double I, you mean?
Double I.
I got 5. X equals to 5.
5. Anyone else? Where's Mr. Bethel when you need him? Juan, I can't hear from you. Ricardo, I can't hear from you.
I still doing double I.
I think they get the same thing with double I.
Okay, question. When it says arrow dot, what does that mean for B?
They just want the inverse, right?
But okay, what the arrow and dot means?
Oh, they're just saying that they're saying is, how do we define H of X, H inverse of X, right? So H inverse of X is defined as what? That's what they're trying to say.
Okay.
For double I get X equals to 5.
All right. So let's do I and double I. So here, they give us H of X. They want to find the value of H of X when X equals to 3. And so when X equals to 3, okay, -3 rather. I like this. It's interesting. I like this. So when X is equal to -3, so they're saying that x is equal to -3. So it's going to be equal to -3 plus 3 divided by 2. -3 plus 3 is definitely 0 over 2. And 0 over 2 is simply 0. Now we want the value of x when h of x is equal to 4. So what must x be when h of x is equal to 4?
4.
Well, we know that h of x is, they tell us it's equal to 4. But we're trying to figure out what x value it must be such that we would have h of x being equal to 4. So x plus 3 divided by 2 equals to 4. And so here we're going to do what? Very good. So we have that 2 times 4 equals to 8. Times x plus 3 is simply x plus 3. We send the 3 over. And so we get that x is equal to 8 minus x is equal to positive 5. Alright, so for those who got that, very good. Anyone got the inverse yet?
Yes, sir. I got 2x minus 3. The same answer from last time. Yeah, so I'm second guessing because I got the same answer from last time.
Anyone else before we move on? Alright, let's go. Alright, so let's look at this. H inverse is the following. So we know what h of x is. H of x equals to x plus 3 divided by 2. We set h of x equal to y, and so we get y is equal to x plus 3 divided by 2. Next thing we do is we interchange x and y. X is equal to y plus 3 divided by 2. The next thing we do here is we cross multiply. And so we get x times 2. 2 times x is simply 2x equals to 1 times y plus 3 which is y plus 3. Next up, we send the 3 over. 2x minus 3 is equal to y. And so y equals to 2x minus 3. And so therefore h inverse of x equals to 2x minus 3. That's how we get our answer. That's what we got, Nancy.
Yes, sir. Advertising.
Very good. Awesome.
Yeah, man. I aced this. I got this in the bag.
Yes.
I wasn't gonna start studying when Beth was sleeping. You know, to get better. I will be back from this walk though.
I know, right?
Mr. Petit. Oh, for paper 2, my only concern about paper 2 is that if we could do the thing where where you enlarge and all of that. I was trying to research it on YouTube. It is sticking, so I just think if next week. I mean, this week when if we got time for paper 2, yeah, if we could show that. Just in case they come on paper 2.
Yeah, sure. So that's how we do that. They have some more functions questions, This one, 2014, how they give it to us. I like this one. I think this is gonna give y'all a run for your money, so let's try it. So what if it comes like this?
You trying to break my winning streak? My winning streak? Hey.
Yeah, the child that managed it.
I saw this how guys don't do that. Just take.
Yes. Wow. When they come big. That's 10. Sometimes they come 10 points. They come 8 points. All right. Do A, B, and C for me, please. All right, just a few more seconds left.
I got A as my answer.
For what?
I got I got A for F minus a half equals C.
Okay.
I do an I now.
Oh, you just finished? That's all the time y'all still on BI.
Word
No,
my
I started. I do the ones that's the easiest, and I was going back and forth because
Okay. Okay.
things get technical.
Aha.
Miss Word my
I heard you answer 8, right?
yes, sir.
Yeah. So for AI, they got 8. How about for A double I?
Petite, I get for A double I get 64.
For A double I.
Yeah, 64.
Okay. So we see. So they got 8 for this one, 64 for this one. Anything for BI? Oh, y'all still working?
I still stuck on IIA. Yes, that's what I don't like how you're trying to break my streak. I trying to make sure it's correct.
That's very
I don't
simple.
like that, Mr. Patel.
Very simple. All right, so let's try it. So let's do AI. So for AI, we have F of negative a half, right? And that's going to be equal to 7 minus 2 in bracket negative a half. We already know that we have 7. These 2's will cancel, and the negative is positive. So you end up with positive. Well, 2 goes into itself once, and it goes into itself once again. So we have 1 times 1, and we have a negative and a negative. So a negative and negative gives us a positive, and 1 times 1 is 1. So f of a negative a half is 8. Next we have g of 4. G of 4 is going to be equal to simply Remember what g is? G is x cubed. So it's simply
Yes, sir.
4 cubed, which is what?
64.
To manufacture happy goods and then change them back to
64. But okay, but when you put it back, wouldn't it still be squared, right? So don't you have to reduce it?
What you reduce?
Because I reduced, okay, I got 64, but I reduced it because I felt like the answer didn't look too high.
Okay, so what happens is we know that 4 cubed is 4 times 4, right? I mean, 4 cubed is 4 times 4 times 4, right? Right? Right?
Yes, sir.
4 times
Yeah.
16 times 4 is
64.
okay. What we get for BI?
Can I get -2?
So that's for that. So anyone else for BI?
This might sound outrageous, but I get 29.
So f of x equals to -11, and we know f of x is 7 minus 2x. So 7 minus 2x is equal to -11. What we're gonna do is we're gonna send the 7 over. So we have a -2x minus equals to minus 11 minus 7. And so it's going to be -2x is equal to -11 minus 7 is going to be equal to negative what?
4.
-11 minus 7.
Oh, minus, 11, 18, -18, sorry. All right.
They go back on the place.
Next up, we have g of x equals to 216. Right, so g of x equals to 216. 216. We know that g of x is x cubed. That's going to be equal to 216. Here we take the cube root of both sides. And so we know that the cube root will cancel the cube, leaving us with simply x is equal to the cube root of 216. And so x is equal to, that should be 6.
Dang, what I get though? I got something like different. Hold on.
Well, this is the answer.
Because I did your instructions, I just. Probably I put it wrong in the calculator.
Cube root. So if we look carefully, 6 times 6 times 6 is equal to what? Well, 6 times 6 is 36 times 6. And 36 times 6 is 216. So the cube root of 216 is 6. You get it?
You broke my streak.
Yeah. Oh, but that's good because it's learning. Now C-I and C-double-I. C-I and C-double-I. Let me know when you get something, please.
This is where we simplify, right?
This is where you composite functions. Enjoy it.
Hello? Hello?
Bonjour.
Mr. Malik.
Anyone get CI?
Next week, Friday is June 3rd.
You know got an answer for that?
Mr. Malik. You tried out, I got 7 minus 2 x cubed. Right.
All right, go ahead, Ricardo. Sorry about that. Nancy, I heard you all follow me. I stepped out for a moment. Sorry about that.
Oh, I was saying what I got, but then I asked the class, but it don't matter.
Go ahead.
Ricardo was saying what he got, but I got 5x to the third power.
That's right. I'm a vicious bird of prey.
5x to the third power?
Yes, sir.
As the composite function? Okay.
And then Ricardo said he got something.
All right, so let's try to CI. Okay, so CI. Let me for this. Okay, so we are trying to find F composed G. So F composed G. Right. F composed G. Okay, sorry about that. So F composed G is gonna be we could write that as this. Right? It's gonna be equal to F with G inside, G of X inside. And so what do we have for F of X? F of X is what? 7 minus 2x.
Yes, sir.
And what is G of X?
That is x to the third power.
X to the third power. That means that wherever we see x, we're gonna put x to the third power, so it's gonna be 7 minus 2 G of X, right? Equals to 7 minus 2, but G of X is simply x to the third power. So it's x to the third power right now. And that's it.
I minus it. Is that okay? I'm. Oh crap! Oh, let me try and say that word. I minus 7 and 2 to get 5, and I put the 3x back.
No, they're unlike terms.
I just thought about that just now. But I was close, so that's what matters. I just forgot about that x. Oh my god.
Yeah. So it's 7 minus 2x to the third power.
Good job, Ricardo.
Okay, next up is going to be G inverse. So what is G inverse? Anyone solved that one yet?
Yes, sir. I got x to the third power.
X to the third power. Okay. Anyone else?
That's the answer.
Does she say that? Does she say that she got? Yeah. That's what she says she got. I know that's the correct answer. Yeah.
Oh, okay.
All right. So let's see.
Left that one because I didn't know what else to do with it.
Okay. So we know that G of X is going to be equal to X cubed. That's what we know, right? The first thing we do is we set Y equals to G of X. So Y equals to X cubed. The next thing we do is what?
We swap them.
Yeah, we swap X and Y. We change X and Y, so it's going to be X here and Y here. So Y the third power. And then we have to solve for Y, right?
I just square rooted both sides and cancel it.
Cube root both sides.
Yes, excuse me, cube root both sides. And it cancel out on the y, and then x would be squared. I mean, to the cube root, sorry.
Yeah, no problem, that's fine. And then we cancel out this cube root with the cube. And so we are left with y is equal to the cube root of x. That is to say that y is equal to the cube root of x. And so therefore,
I have questions for you. Why we cube rooting the x when it ain't like a
when it's not what?
What's the opposite of cube? What is the opposite of cube rooting? To the third power, right? Why like we cubing it if it's not to the third power?
You mean the x?
Yeah.
Okay, good question. So the reason why we do that to the x is because whatever we do to one side, we have to do to the other side. And so here, in order to solve for y, we add the cube root both sides. We add the cube root the y because we have y cubed, right? We want to get rid of this cube on top. So the only thing we could do is cube root it, right? The only thing we could do so that we could cancel out these things. But whatever we do to one side, we have to do to the other. So that's why we had to end up cube rooting x as well.
Okay. I just thought you only like do the cube roots or like the square root if like if it's the 3 or if it's the 2. I don't know if I explained that right.
You mean on the x? I know what you're talking about.
Yeah.
But here with vice part, when we're trying to solve for y, and so we have to cube root both sides.
Okay.
Mr. D, for AI, is there any other way to find the answer?
AI, yes. AI.
AI, yeah.
Yes.
The first one, yeah.
Yeah, there's multiple ways.
Because I did 7 minus 2 in brackets -5. Negative 0.5 in here.
Yeah, negative 0.5. Yes, that's another way. That's another way. I thought about saying that, but I just didn't. But that's another way to turn the decimal.
For C, can you write it like a different way? Like you see how you have it? Can I just put like x to the third power?
The third power. This is the third power. Be careful. This is the cube root of x. Big difference.
So I can't write it like the other way.
You mean
The cube way.
Like that?
Hmm.
No, no.
Because I had that one, the one you have, but I did like my final answer, to be honest. I drop it and I just square it to the third power.
No. Definitely not. The only other way that you could write this is if you say x to the power of 1 over 3. It's a fractional exponent. Those two mean the same thing. Other than that, you can't.
Okay.
Can't change them.
All right. Thank you.
Mm-hmm.
And that's a rule, right? So that applies to all.
Yeah. So if I have the square root of x, right? We know that that's x to the power of a half, right? If I have the cube root of x, we know that that's x to the power of 1 over 3. If I have the fourth root of x, that's equals to x to the power of 1 over 4, and so on.
Thank you. You can go back to the questions.
No problem. Mr. Bethel, where are you?
Right here.
Surviving? Swimming or drowning?
I just came back from my walk.
You want to walk with you?
Yeah.
You
I
feel
walked to the park and back.
Did it work?
Yeah, I get refreshed.
Mm-hmm. Okay then. Hey brother, let me see you refreshed.
I came back when you say f of x equals negative 11. And then I was equals to 9.
Okay. Okay.
I need to walk right now.
Mm-hmm.
So this C, that's just a new way to do functioning.
Well,
C.
yeah, there's a different way of writing it. Yeah.
So what the arrow for?
That's just their notation, bro.
I guess I get the FG of X. I get that, but with the arrow, like, what's the
Arrow.
purpose of that?
My teacher always used to say, what's the word he used? He used to say, to every time you write that arrow, he used to use one word. It doesn't come to mind right now, to be honest. But it just refers to the same idea as this, right? That once you put in this input value, you get the functional value. I honestly can't remember the word for that arrow.
Result or conclusion?
Not results, because it's saying that x. All it's saying is that x goes into, right? So x is your input value, right? So x into a particular function, right? So but I honestly cannot remember precisely the word that is used.
Which would say we could have one more practice of this type of function. I don't know if there's any more.
Say it again.
Can we get more practice with this version? One more, please.
Um, okay, so we did this. We did this. 2014. I guess we could do it. 2013. I try this. Oh, and then we also have to do B. All right. All right. So how about it? So do A, B. Just A and B. A few more seconds left. Attempt as much as you can. All right, that's time. What do you get for AI?
1.
I got 5/5.
Which is
So I guess that's equal.
1.
uh good. Anyone else for AI? Anyone else for AI? All right, what do we get for A double I?
I still working that one now.
Okay, still working. Okay. Remember, the exam is not for 4 hours, neither 5 hours, neither 3 hours. How long this exam is anyway? Probably 2.5 hours. Y'all only need an hour for this. Uh, 9 to 10, 10 to 11. Yeah, 2 hours, 30 minutes. So make the best use of the time.
For B, I got we even get a tiny cup. That's
What do you get, Nancy?
sorry. I have to go back and add G. I thought it was X in the bracket, but it's 3, so I got to
Mary tried to go for the
substitute 3 for X. Sorry.
Oh, okay. I don't want anyone to add Nancy, you know. Come on. The rest of you, let's go.
Okay, I think it could be wrong, but I got for I got 3/5.
3/5, okay, no problem. Anyone else? Anyone else? Lloyd, Ricardo, Alicia, what's happening?
Stuck.
Stuck? Okay.
Mr. Mate, we doing I, right?
Yeah.
Uh,
First for numbers for I, that's A3, I think. I got X equals 3.
X equals 3? Okay.
So
Okay.
I'm doing the inverse now.
No problem.
Mr. Petit, I tried A double I got negative 25.
Negative 25. Okay. All right. Move on to a triple I then.
So for y inverse, I got x minus 7 over negative 2.
X minus 7 over negative 2. What are you saying, Nancy?
Yes, sir. But can I put negative at the denominator? Or just put it like in the center just to say that it's a negative?
Doesn't.
All right.
What does that mean? The same thing.
For 2, you're supposed to get a whole number.
Yeah. Let's get a whole number. All right. So let's begin. So
For I get 1.
for I, you get 1. Okay.
Yeah, and for double I get 3 over 5.
3 over 5. Okay.
And for triple I get 5. And for number 4, I get x minus 7 over negative 2.
Over negative 2. Okay. Okay. All right. So let's go ahead and do G of 2. Okay. So G of 2, simple substitution. And so
For IV, I got 9 minus 2x over 5.
9 minus 2x over 5.
The church can't be
Yes, sir. Minus 2x over 5. That's to be or just
we need to
wait?
make it like something we
You could continue. You could continue because B might give you a run for your money. Okay, G of 2. So this is the first one. A I. So here we want to do G of 2. All right, and so all we're doing is substituting, right? So we're using this function G of x equals to 3x minus 1. So instead of writing the x, we're going to write 2 minus 1 divided by 5 is going to be equal to 6. So 3 times 2 is 6 minus 1 6 minus 1 is definitely 5. So we have 5 over 5, which is simply 1. The multiplicative identity. All right, so that's 2 I.
It's GF and then bracket 3.
Okay, yeah, so GF in bracket 3. There's 2 ways we could do this. The way that I suggest you do it is the way how I believe they want you to do it. And so the first thing we're gonna do is we're gonna figure what is f of 3. Okay, so let's find out what is f of 3. F of 3 is what? We're using this function. So that's 7 minus 2x. But this time we put 3. And so f of 3 is going to be equal to 3 is going to be equal to 7 minus 2 times 3 is 6, which is equal to 1. So that means that f of 3 is equal to 1. Let me make that clear. F of 3 is equal to 1. And so what we need to do is we need to calculate that. We need to calculate what is g of 1. So g of 1 is going to be equal to 3 in bracket 1 minus 1 all over 5. And so we have 3 times 1, which is 3, minus 1, which is 5. Sorry, 3 minus 1, and then divide by 5. Then 3 minus 1 is 2, so it's 2 over 5. Okay, and the reason why we do it like this is because this is a composite function. So the first thing they're telling us to say, evaluate what f of 3 is. Then whatever f of 3 is, put it inside g. Again, evaluate what f of 3 is. Whatever inside f of 3, you put it in g. Okay, so that's how we do that.
I did that, but I got 3 over 5. Why is that?
I don't know. It's 2 over 5. Even if we do it the other way, the other way is to find what the expression is and then substitute. Excuse me. And then substitute. That's another way. But I mean, you can't go wrong. I mean, if you put 3 into here, that's 2 times 3 is 6. 7 minus 1. Sorry, 7 minus 6 is 1. Alright, and then we put 1 inside here. 3 times 1 is 1. 3 minus 1 is 2. 2 over 5. Can I get 3 over 5? Okay, so it's 2 over 5. So that's the way that they want you to do. Solve for f of 3 first. Then put whatever you get for f of 3 inside the g to get g of f of 3, which is 2 over 5. Nancy, see how you're going wrong?
Yeah, I forgot the negative 1.
Oh.
Symbols of that I shouldn't be forgetting. Anyhow.
Alright, so that's that. And so now we're gonna do x is equal to where f of where x where f of x is equal to 1. And so so this is going to be triple I so f where f
But
of
the other one was kind of new though.
that one is kind of new, eh? Yeah.
Better double I.
Yeah. But you know, it's not really new, you know.
No, it's not really new, but I'm able to switch it up really.
What you mean?
I did it the other way.
The method. He used
Five.
the method the
I
other
did.
way.
What you did?
Shoot, I already erased it almost empty. Right there. I did 7 minus 2,
Uh-huh.
and I multiplied it by 3.
Uh-huh.
Uh, Never mind.
Okay. But it's the right way. Okay, so do f of 3 first, and then do after you finish get what f of 3 is, then put it in for g.
Yeah, like basically what I did, everything what was x, I multiplied it by 3. Like I switched out and I went 3 inside of it.
Okay.
Mr. D.
Yes, sir.
So whenever we get a question like this again, we do the second letter phrase.
Yes, it's the baby first, and then once we get what the baby answers, we put it inside the mother.
Yes, I did the first letter phrase. All right.
We work from inside out. Okay. All right. So we know that f of x.
I thought that was wherever you see G, you put F of X.
You could do it that way, but then you add after you get your expression, you just have to substitute for 3. So we want where f of x is equal to 1, right? And so the f of x is equal to 1. So f of x, we want x where f of x equals to 1. So what value of x would make f of x equal to 1? So we already know that f of x is 7 minus 2x. And that equals to 1. We send the 7 over.
Miss Petita, in this case, why wouldn't you say negative 2 times 1?
Negative 2 times 1.
Okay, you see where you go with negative 2x? You would remove the x and you put 1 inside that, and you would put like a bracket around that.
Oh, the reason is because when they want you to do that, they would say f of 1, right? So if they want you to substitute, they'll put the 1 inside. But here they tell us that f of x equals to 1. That's different. So clearly, what happened is the 1 is not inside, the 1 is outside.
Okay, so they want us to know what is x.
Yeah, they want us to know what is x. Yeah. All right. So we have 1. When we send a 7 over, it's going to be plus. I'm sorry. When we send it over, it's going to be negative. So negative 7. And it's going to be negative 2x. Okay. And so negative 2x equals to 1 minus 7 is negative what?
Negative 6. Negative 2. And then you get positive 3x equals to positive 3.
Negative 6 divided by negative 2.
Something I finally get right. Apart from the first one. No, because the second one bothered me. How I forget? You know?
Yeah.
Negative 1.
So then that's that, and now we need to find the inverse of f. The inverse of f. So we know that this is what I phi. And so what happens here is we're gonna what? We're gonna do F inverse of X and to figure what that is. Oh, I started this question wrong. We need to find out what the inverse is. So we start off with our function. So f of x is going to be equal to 7 minus 2x. Seven minus 2x. We set y equals to x is equal to 7 minus 2x. We interchange x and y, so x equals to 7 minus 2y. We send the 7 over, so x minus 7 is equal to negative 2y. Then we divide top and bottom by negative 2. And so these two cancel. And so therefore we have y is equal to x minus 7 divided by negative 2. It's the same thing as saying y is equal to x minus 7 over negative 2. And so therefore f inverse of x is equal to x minus 7 divided by negative 2. Any questions on that?
No, sir.
You got that in, Nancy?
Yes, sir. It's only I said it's at about.
All right, moving right along.
Steve, go back on the questions, please.
No problem. All right, so next up for the final 3 marks. It's a lot of points though. Wow, 3, 5, 6, 7, 8, 9, 10, 11, 12 points on functions alone. Wow. Wow, that's a lot. Y'all know this coming, right? GF. The function GF. So let's go. So we want GF, right? A simplified expression for GF. So GF is V. So GF of X is going to be the same thing as the parent function is which one?
The G.
The baby function is
Yeah.
Yeah.
very good. And well, G is, what is G? 1 divided by 5.
Mr. Petit,
Yes, sir.
I started, but I froze.
You froze. So substitute now, right? So
I
Yeah, when I saw that get technical, but I finished it though.
I have 3 open bracket
mhm.
7 minus 2x close bracket minus 1 over 5.
All right, so just distribute now, right? So it's going to be 3 times 7, which is what?
That's 21.
21. 3 times 2,
6x
6x minus 1, all right, divided by 5. We bring the like terms together, so it's going to be 21 under x, right? I mean the 21 under 1. They are like terms, so the 21 and negative 1. The negative of the whole negative 1. So 21 minus 1 minus 6x divided by 5. Divided by 5. It's going to be equal to 21 minus 1 is 20. Minus 6x divided by 5. 2. Okay, that's good.
That's the answer.
That's the answer.
You know, Mr. Petit, you multiply them for real?
But Mr. Petit,
Hey,
I get this answer, but I get it for g of x in brackets 3.
good. So what you're supposed to do is
So I get it for the wrong question.
no,
I legit add them.
you're supposed to be successful once you get that, right? You substitute 3 into this. So it's gonna be 20 minus 6, 3 divided by 5. And so it's gonna be what? 20 minus what? 6 times 3 is 18 over 5. It's gonna be what? 2 over 5. So this is the same thing for I. That's another way to do it. Okay, so that's another way to do I. First, you have to find the function and then substitute it.
Mr. Petit, why didn't you add 3 and multiply 3? Because I'm so confused.
Because when you have them together, that means multiplication, right? So
I actually add a plus sign. Something's wrong with me. I don't know how. I'm looking at it.
yeah, it's multiplication.
Okay, to be clear, because anytime I do it like this, I always add a plus sign, right? So how am I supposed to know when to add a plus sign and when to just multiply?
Why are we adding plus signs? You never just add plus signs.
I used to just put a plus sign.
No, you never add a plus sign like that.
Did I be doing something seriously wrong?
Yeah.
I still don't get that. How I didn't thought of multiplying it.
Yeah, you use the distributive property. And
Because there was a -1, so I figured if I add 3 plus 7 and then minus it from 1, I would get 9, and then I just bring down the -2. That's how I was thinking.
yeah,
Wow. Okay, let me write it down.
yeah, be careful. So Mr. Bethel, you see what you could do, right? To get you to your f of 3.
Yeah, so
Okay. But I don't think that's the way that they wanted us to do it. And the reason why I said is because, well, they asked us for the function all the way down to 5. And so they didn't want us to do it this way. They wanted us to leave the function itself for the last thing.
Mr. D, I looking at this shape. I don't see how this any different from the other simplified expression. Like this one different.
Which one?
This one what you have on the screen.
It's different?
You multiply.
Yeah, it is different. Yeah.
So you didn't add.
I didn't add because if you look carefully, right? Look carefully at all the ones that we had before. Like so, let's say the one that we had with this one, right? When I substitute this thing into there, right? Notice this was what? 3 plus f of x, right? Clearly it was addition sign, so we had to add. It wasn't 3 times x, it was 3 plus x. If you look at the next one again, that we had also before that, it was f of x plus 7. See that? So we had to add it, right? This is the first one where we have a number in front of the function. So this is the first time we have it, right? And this implies multiplication. So 3 times f of x. Okay, so that's why you multiply it like so. So it's just a different function. So you have to work with the function that they give you and see it like that.
how we get the 3 again?
The 3 was given as a part of the function. So this is 3x minus 1 over 5. And so instead of putting x, we put f of x. Okay. All right, Mr. Bethel?
Okay. So you distribute the 3 to f of x.
Yeah, I distributed it, yes.
Okay, I think I see it.
Yeah. Because the multiplication, yeah. So yeah, this is 3 times x, right? So it's going to be 3 times f of x, because f of x is now x.
I'm just saying, usually we only use up to x. But now this time they put a number before the x.
Yeah, yeah, and then usually it's a plus, right? And so we had to add them, but now it's multiplication that we have to do. Just be careful when they switch it up.
So I know that. Okay, so when they put the x, when they put the 3 in it, we just substitute for the 3, and then when we put the we have the x, but then we have to redo it. We just would multiply.
So when they have 3 inside of it, right?
Yeah.
You do it like how I showed you originally. You find what f of 3 is, and then you substitute what f of 3 is into g, right? That's how you do it when you have the number inside. When it just have x, they just want the expression. And so that's when you just substitute f of x and just get your expression. So they don't want you to find any value on it. They just want the expression. Understand, Nancy? Or no?
I can practice a bit more and see if I get it. Yeah.
How much points this right?
10. You mean this individual question or just functions on the whole?
On the whole, the entire 10?
Well, this is 10. The top part is 10. The bottom makes it 12. Okay, so let's do the bottom. The bottom says the function t is defined over the set of integers from 30 to 40, excuse me, inclusive as t such that, well, t is defined in the following way, that the functional value is going to be the remainder when x is divided by 9. And so, oh, I remember the word he always used to use. Oh, map. He would say x map onto. That's the word, Mr. Pepper. Yeah. So the arrow means mapping onto. And when we say mapping onto, the idea is the same thing as as putting it into like an input, like input values. Okay, so x is going to go into this function. Sorry, x is going to go into the input values is going to go into the function and give you output values. Now x is the function t is defined over this set of integers, and the way that we get t is that it's going to be the remainder when x is divided by 9. That's what t is, the remainder when x is equal to the remainder when x is divided by 9.
Hello, Mr. Petit.
Yeah.
Sorry, I step out. Why the class quiet?
Okay, so what I'm saying is that we have this function t, right? And t is defined over a certain set of integers. So it's gonna be between 30 and 40, but including 30 and 40 as well. And so this is all this is saying is that this is all the values of t that is allowed, right? So you can't, t will never be 1, t will never be 2, t will never be 3, t will never be 4, t will never be 100, t will never be 1,000. T will always be between 30 and 40, but including 30 and 40. That's what this is saying.
Okay.
The next thing it's saying is that well, how do we define t though? Well, t is going to be the function that is going to accept its x values, but its output is going to be the remainder of the x value when it is divided by 9. And so it's very simple. They're just putting this in a long way, but what it's basically saying is whatever your x value is, right, divided by 9, and then your y value would be the remainder, or in this case your t value would be the remainder. So That's the first thing we're gonna do. We're gonna divide 34 by 9. Okay. So if we divide 34 by 9, 9 goes in 34 how much times? Hello? 9 goes in 34 how much times?
You said 9.
Please use the calculator. Please. 9 goes in 34 how much times?
I don't remember some good. I actually could use the calculator.
My 9 and the 34.
3.
What?
Nah, you see, I use calculator, so now I can't do the remainder.
What is 3 times? What is 9 times 3?
27.
Thank you.
But I wanted to give you the remainder.
That'd be 7 over 9.
All right, so it's gonna be what? We gotta borrow.
So that would be 14, 7, and then you have 0.
So the remainder is what?
7.
The remainder is 7. And so that means that t of 34 is gonna be what?
7, I guess.
Write down about t of 34. But it can't be.
It's
7.
1 point. So, like, it's just one thing we doing?
But it can't be. I like how they did this. It cannot be 7, you know. No. Okay. It's good. It's good. They're not saying that t defined over the set of integers. Defined over. T is defined over the set of integers. 3 to 1. I'm trying to figure out if this t if this refers to the x or refers to the t. Like, are they referring to the domain or the range? The function t is defined over. Yeah. So that would be undefined.
Mr. Petit, you said 34 divided by 9. Why y'all got 7?
No, the remainder is 7.
Okay.
You understand what I mean? Like, the remainder is 7.
My question is, can you choose any number to go into 39? I mean, like, okay, let's use 39. So can I use 40?
Okay, look. Let's say, right? Let's say that we had t of 35. What would that be? Divide 9 by 35. You don't have to do rocket science. 27, 28, 29, 30, 31, 32, 33, 34, 35. So the remainder is.
Sorry.
I got 18 out of 20.
All right, t of 36. What's the remainder?
What number are we using?
We divide by 9 again. That's what it says. The remainder when x is divided by 9. Isn't x 36? So we need to figure what's the remainder when x is divided by 9. What's the remainder when 36 is divided by 9?
Four.
0. The remainder, not quotient, the remainder.
And it's 0.
What's the remainder when what's the remainder when 9 is divided by 37?
That's 1.
1. Very good. What's the remainder when 9 is divided by 38?
2.
What's the remainder when t is divided by when 9 is divided when 39 is divided by 9?
3.
3. And it continues all the way up to 8, and then it recycles again. Okay. So the answer is t of 34 is equal to 7. This here, when I say t is defined over the set of integers between 30 and 40, 30 to 40, that means that its x values have to be between 30 and 40, not its output like I was saying, but its x values have to be between 30 and 40. Okay.
So is that even necessary if they doing the numbers for us?
No, that's necessary. It's necessary for double I. Okay. Because they're saying give me the x value that I need such that t of x will be equal to 3. Right? So they're basically saying which x value I could use such that when I divide it by 9, the remainder is 3. Okay.
39.
39. Right, 39. But 39 is not the only one that could work. Right? Let me show you what I mean. 39 is not the only number that could work. So say
Because they can reset.
yeah, because it could reset. So for example, I can give you another number which when you divide it by 9, its remainder is 3. So try 21. What's the remainder when you divide it by 9? So 9 times what is the closest thing to 21?
9 times
2.
9 times 2. So 9 times 2 is what?
18.
18. Add 3.
21.
21.
21. So 21 could work because if you divide 9 by 21, the remainder is 3. 39 could work because if you divide 39 by 9, you get 3. 48 could work because when you divide 9 by 48, you get 3. Why? What's the closest thing to 48?
45.
Pardon me?
What's the closest multiple of 9 that is closest to 48?
45.
45. Add 3.
48.
48. Very good. We could also use 57. Why could we use 57? Can y'all hear me? Hello, can y'all hear me?
Together.
Can y'all hear me?
Yeah.
Okay, we could also use 57. Why? Hello? We could also use 57. Why?
We can hear
Because
you,
the
but
closest one is 54.
The closest one is 54. Add 3.
At 57.
57, good. So now you give me the next one that I could use.
66.
66, very good. Why?
Because the closest is 63.
Mm-hmm.
And you add 3.
3, good. All right. Someone other than Bethel, give me another one that I could use.
I am confused with the numbers now. Because you're dropping in, I don't understand.
Nancy.
Yes, sir.
All right. What is your say a 9 times table to me?
9, 18, 27,
Okay. All right. Start with
30.
Start with 18, right?
Uh-huh.
If you look at 21, right? And you look at the multiples of 9, right? Which one is closest to 21?
18.
18, good. Add 3 to 18.
You get 21.
Good. Now, 9 times 3 is what?
27.
27. Add 3.
27.
Add 3 to 27.
You get 30.
30. So that one we skipped. So 27. 18. So we skipped 27. So it's gonna be remainder 3. So why we have 39? Okay, good. Give me the next one. After 27.
36.
36. Good. Add 3.
39.
Good. So 30 could work because when you divide it by 9, you get remainder 3. 39 could work because when you divide it by 9, you get remainder 3. All right, let's look at 48. What's the closest multiple of 5? What's the closest multiple of 9?
45.
45. Add 3.
48.
54 could work. Sorry, 57 could work because when you divide 57 by 9, you get 3. Remainder is 3. Because 54, 9 times 6 is 54. Add 3 is 57. Why can 66 work?
Because following the pattern.
Go ahead, Nancy.
Same thing. I was going to say because you get the same remainder 3.
How? What is the multiple? What's multiple of 9 gives you something that is closest to 63. 6 closest to 66.
63.
Good. Add 3.
66.
Good. Now give me another one.
Oh, 72.
But
Can 72 work?
no, 72 can't work because when you divide that by 9, you get 0.
So 70.
When you divide it by 9,
75.
the remainder is not 0. So what could work? Did you say?
75.
Good, 75. Because the remainder here, when you divide it by 9, is 3. Good. So all these numbers are options. So 21. So 21 could work. 30 could work. 39 could work. 48 could work. 57 could work. 66 could work. 75 could work. And we could continue doing this, right? Forever. But they say that you only could choose integers between what? 30
to 40.
30 to 40. See what I'm saying? And so that's why um that's why this matters. because they didn't want you to continue going on forever and ever and ever. So the only ones that we could choose is 30. And what else? 39. Okay. Now it's only for 1 point. So um I'll put all two if you ask me, because they say x for which. Here x equals to 3. It's only for 1 point. I don't know if they want us to give them all two, but let's just put all two. So x also, and x equals to 30. That works too. Because 27, 28, 29, 30, that works. And then 36, 37, 38, 39, that works. So either one could work. And they say inclusive, so yeah. So that's what that means. Okay. Any questions on that?
No, sir.
So it looked weird, right? It looked weird, but it's saying something that is pretty simple. What do you think?
Yes.
All they asking you to do is find the remainder. All right, and so that's that.
I have a plan I can help you. I've been dreaming about it my entire life. Find your humanity. Have any of you ever had a dream?
Okay, so
I did have a dream one of those days back in the day.
keep the dream alive. Okay, so we did that.
Reality made me lucid.
Don't let that do it too. Okay, so we did the one for 2018. We did that. We did that one. We did the one from 2019 as well. What we haven't done is, let me see if 1999 have any functions. So hopefully you can leave today with at least one skill under your belt, which is functions, because we really tackled that today. What would you say?
That's all.
Alright.
Let's put the bearings.
Bearings, yeah.
Next week, I'll spell like what's on?
Yeah, we have to look at it. Maybe we could do it in class, eh? To just get a good thorough through on that. Let's do this one. This is this is good. I like this. I like this. 1999. Awesome. Let's do this. I think it's the last one on that page that we haven't done. So let's do this.
What's up with the what? Yes, BDCSE made.
I don't know. I don't know. They have all that on the history thing. I can't remember, honestly. So we have H and K. Do A through E for me, please. Especially E. I would like to see how y'all answer that one. And remember, it's 3 points. Oh, that's only 2 points. Okay, so
I don't have the more pages in my book. Can I be exempted from the?
put right on your hand. All right.
I got 15 for A.
Put again.
I said I got 15 for A.
15, you said.
So
For A, I got 1.
You got 1.
Yeah, I second answer.
Okay.
I'm gonna erase what I said. Never mind.
Okay. What if your one's right, Miss Odisha?
Doubt it.
Ricardo and Nancy could be wrong.
For B, I got -1.
For B, you get -1. Okay.
Yes, sir, but I ain't gonna more paper in my book. That's it.
Your hand. Paul, what do you know that using that spot? The hand or the right?
Hey, my hand's sweaty.
Try it. Use on your sister's book. Something will work. All right, so any other answers for B? Any other answers for B?
See, they get the same thing.
What is that?
That's -1.
For C, I got 6. I mean, X
So where you
plus.
right? That's what I want to know. Where you right?
I write in my hand.
Yeah, right.
I can't print in paper. Relax.
You know that was there all along. Giving excuses. Go ahead.
You know, it's a struggle to find printing paper. You know. Okay, D. When it say HH, what that mean?
Put H in H.
My printing paper turned black when it's all that question.
I give up on functions, man. I'm frustrated. I can just wait for your answer.
Huh?
I said I give up on functions, man. I'm frustrated. So I
No.
just wait till you.
Oh, you be getting it. Don't give up on functions, man. Um, no, don't give up. It takes a while, a learning curve, and we get it eventually. Because they always come different. They can always change the function. So
Question: we're simplifying H into H.
H into H.
I don't like that.
Yeah, I know, right? They probably meant to put K, but in the printing process, they messed up. But it says H, so we have to respect that. All right, so let's go. Mr. Bethel, quiet as a mouse. Not at all.
I get A, B, and I working on C right now.
Okay. All right.
Okay, give me a minute. Let me just
Sunday.
Okay, for A, I get 1.
Uh-huh.
And for B, I get -1. And for C, I get x minus 6 equals k inverse of 1.
That's what I get, but I was trying to do some more. That's why I get stuck.
Okay. It's in biology. It's simple. Simple. All right. So, all right. Since we had it, let's go.
for G. I got Oh gee, Lord, give me strength. I get -7 plus 4x.
You wasn't watching? You was a dog.
That's
D.
was watching.
Yes, sir.
For letter D, all right. I mean, how do you word it?
Yes. I mean, put H in H.
Well, I get 7 minus 2, open bracket, 7 minus 2x, close bracket.
Okay, that's a good
Then
I got that too. I got that, but don't try to simplify that even more though, because you got 2. Yeah, you have to simplify that. Now that's where you will lose your head.
7 minus 14 minus 4x.
Yeah. Yes. Be careful though, because a negative and a negative is
Yeah, I finished it though. Hold on.
a negative and a negative is a product, so it's not -14x. It's +14x.
Say it again.
It's not -14x. It's +14x, because a negative and a negative is a positive.
All right.
It is a -7 though. Hold on.
It's like
It's +7 up there. 7 minus 2.
it's
So it's
+4.
positive.
+4, not -7. Not -14. +4.
And then we work. We'll see.
Let's go. So let's actually get the working in. So we want H of 3. So this is H of 3 is gonna be equal to, again, wherever we see the x, we put 3. So x is here. We put 3. X is also as a 7 minus 2x. Well, at least everybody should be able to get this one. Everyone should be able to get H of 3. If you don't get H of 3,
So out of 10, we can get 1 right.
at least 7 minus 2 is going to be 2 times 3 is 7 minus 6 is value of x for which k of x is equal to 5. So this is like every the value of x for which k of x is 5. equal to what? X plus 6. Nancy, you might be.
All I get here is printer paper.
Oh boy. You send the X over. Sorry, you send the 6 over. And so X is gonna be equal to 5 minus 6. So X is equal to -1. Alright. Okay, and then we have K inverse. Okay, K inverse. And so let's do that. Plus C, I suppose. So K inverse is going to be K of X. Then that equals to what? X plus 6. That's X plus 6, I suppose. Good, yeah. So when we see K of X, will be set that equal to Y. That equals to X plus 6. We interchange the X and Y, so it's going to be X is equal to Y plus 6. Then we solve for Y, send the 6 over, so X minus 6 equals to Y. Anyone got that?
I already stopping right there, man. I don't
Yes,
know what.
sir. Yes, I got it.
Excellent. Very good. So therefore, K inverse is going to be equal to. Samantha, what you get for this? K inverse.
That's what I got. That's what I was trying to figure out from after that. That's why I get stuck and I say, maybe it's the answer, yeah.
It is. Just once you solve for Y, it is the answer. So K inverse of X is going to be X.
Mr. Petit, in this case, do we have to put K inverse of 1? X is equals to X minus 6, or we just say Y equals X minus 6?
It's K inverse. That's what you do. K inverse. Good question. All right, next up we have the moment of truth.
Mr. Petit, for the final answer, I got -7 plus 4x.
So what, you mean the one we're about to do?
Yeah, for D.
Okay. So D,
7 plus 4. Yeah.
so we have H of
Sam.
H of X. Okay. That's going to be equal to, well, whenever we see H, we put, so whenever we see X, we put H of X. So it's going to be 7 minus 2 X, but you're going to put F of X instead. Not F of X, sorry, H of X. And so it's going to be equal to 7 minus 2. H of X is again 7 minus 2x. And so it's going to be equal to 7 minus 2 times 7 is indeed 14, and negative 2 times negative 2 is going to be positive. 2 times 2 is 4x, and 7 minus 14 is negative 7 plus 4x. Right. So that's how we get that. For those who got that, very good. For those who tried, awesome.
For the last one, I got x equals 1 over 3, and then I do that long thing as x is less than or equal to 1 over 3, then h. You know that long to do? Yeah.
All right, so E is it? So we have to, first of all, we know that these two are what? Linear functions. How could we tell?
Because they're not squared.
Yeah, because the highest power of x is 1. So it's going to look something like how it looked the first time. So if we use a red one to determine h of x is going to be the increasing function or decreasing function?
Decreasing.
Decreasing. How do we know that?
Does that have a negative?
Have a negative slope, and the slope is negative 2. So we know that h of x is going to look something like that. It's going to be decreasing. K of x is going to be increasing, right? Why?
It's a positive.
It's rising.
So it's going to look something like that, and then they're going to meet somewhere, right? And so our job is to find this intersection point, because once we find this intersection point, for all values of x after this point, k of x will be greater than h of x. Okay? And so we first have to find the intersection. So we have to set h of x equal to what? H of x equals to, you know what? Give me a clean slate. Let me just start doing it. So we have h of x equals to k of x h of x is what? 7 minus 2x. K of x is what? X plus x plus 6. What do? We send the x over the equal sign. We send the 7 over the equal sign. It's going to be equal to negative 2x minus x. And so we have 6. 7 is sent over minus 7. And so it's going to be equal to negative 2x minus x, which is negative 3x. And so 6 minus 7 is what? 6 minus 7.
One.
It's negative or 1.
Divide both sides by negative 3. So we get that x is equal to 1 over 3. Yeah. We note that h of x is a decreasing function and k of x is an increasing for all values of x. Thus, if x is greater than or equal to 1 over 3, then h of x is greater than, so h of x is less than k of x. Alright, and that's how we get that. Any questions for me on that?
No, sir.
All right.
Mr. Bethel,
Now time to
I
go to
got
my.
this one right this time.
you got this one right? Okay, that's good.
Yes, sir.
Right. Alright, so how do we feel about functions after this marathon?
I may get 1 or 2 now. Or the 10.
It ain't really difficult like that.
It ain't
I
really
didn't get. I get 10 out of 10. I
Hey,
confident. I just
Well,
think
start.
I confident in identifying them now. I could tell a function whether I have the map or not now.
yeah, well, yeah. Yeah, anyone else? How do you feel about functions? Areas you feel you need to improve or you got it?
Only the invoice like the difficult at times.
Okay. One, how you feeling with functions?
Okay.
Okay. Alicia, what's your take? I want to see what please.
When she say she
She
taking a
gonna
break
sleep.
from function.
I think you should still be here. Miss Rackley, you here? Well, I guess she had. Yeah. All right. So, well, thank you for staying tuned. That was uh, what, 4 hours? Just functions.
So,
Go,
do some.
go ahead, Alicia.
I have to do some practice sheets on it. Hopefully by next week, cause we have this next week, right? I think the 2nd of June. So like I probably have to do this like every day this week.
Yeah.
And yeah.
Good. Yeah, to get a better grade. All right. So, um, thank you for staying. Have a wonderful rest of the night, and see you on tomorrow at 6 p.m. God's spell. Have a wonderful night, everyone.
Have a good night.
Peace.
Good night.